I don't know.
All right, so let's run through this one quickly, and then I got a worksheet version that you can do in groups at a desk, and make sure we can nail this down. So the basic approach, I started this already, right? We start off with node A, that's where we're beginning, and we relax all the distances. So there's a distance of 1 from A, so node D is 1, this is 2, this is 5. These numbers you're writing are distances from A. And we don't know that 5 is the best distance possible from A, but we know we can at least get there in 5 by taking this link. It's possible that, you know, there might be some path that goes through here and ends up getting us there in only 4 steps. But we know the worst we'll have to do is 5. Node E we haven't explored yet, so the worst we're going to do is infinity. It may be unreachable. Okay, so we relax the nodes that are adjacent to A, and now we say what's the closest node to A that we haven't visited yet. Well, this one is 1, this is 2, this is 5, 1 is the closest, so we mark that as visited. Once we mark a node as visited, we can say the shortest path to here is 1. Okay, we're not going to do any better than that. So now we relax any nodes adjacent to this node that we just marked, and there's only one node, which is node F. Okay, it's a distance of 1 to get to D and 7 more to get to F, so the distance to here is at worst 8. And now you look at the distance to all nodes and you find the closest node to A. So we're looking at an 8, a 2, a 5, and a bunch of infinities. And the closest node is going to be 2. So we're going to visit that next. Now if you want to know the path while you're doing this, you also need to keep track of the path. So our path to A was just A. Our path to D with a distance of 1 was AD. Our path to C was AC, our path to B was AB. And now we relaxed a node from D to get to F, so the path to F is however we got to D, which was AD, followed by F. And then we found the closest distance that we hadn't visited, that was node C, so we circle that, and now we're going to relax from C. So from C, the only node we haven't visited yet that's adjacent is E. Takes 2 to get to C, another 6 to get to E. We can get here in a distance of 8, and the path is first get to node C and then go to node E. There's our ace again. Okay, now we find the closest node. We've got an 8, we've got an 8, we've got a 5, looks like this one, and relax what's adjacent to that. Well, their only node adjacent is this node here. 5 to get to B plus 1 is 6. That's better than 8, so we're going to change that. We're going to relax it to a 6, and the path is first get to B, AB, and then go to E. And you just keep doing this. So I think everybody's on track with that. Avoid the temptation, though, to kind of look ahead and say, well, you know, this is a ridiculous path because it's shorter to just go this other way. Right? Your algorithm doesn't do that. Your algorithm is just a piece of code, and it's got to go through the same set of steps each time through a loop. So you want to make sure that you know what that algorithm is, so that at some point in your life you can code it up. All right, so I have a more fun graph. And if I give this to you on a test, Friday, or some other time, I would generally give you, say, 8 copies of the same graph, and I would ask you to go through Dijkstra's algorithm, but make sure that when you need to change something, right, more than one change, you go down to a new graph. So for example, I change this from infinity to 8. That's fine. If the next thing I'm going to do is change this 8 to a 6, I would go down to a new picture of my graph, right? Copy the information I already have, and then go ahead and make that change. So that as you go from one graph to the next, you can tell exactly what got changed. Okay, now if I'm changing these from infinity to 4, 1, and 2, I can do that in one picture. Right, because the order doesn't matter, but the goal is to be able to see from looking at this exactly what you did in what order. Make sense? Okay, so I made like 30 of these, and I made them single-sided so you can put them side by side. Sorry, trees. Let's do groups of like 3 people at the most, and grab 2 sheets of paper. And you can move tables around or whatever, and check each other, work on this together, but convince yourself that you're doing the right thing, and raise your hand if you want me to come over and look at what you're doing. Okay, so groups of 2, 3 max, and take 2 sheets, and I don't know if you need more than 8 copies of that, but we'll see.
Can't pass me too.
Sure.
Yeah, why'd you send me? This doesn't make sense.
Yeah, it does.
How many
And you're
sheets do
like
we need?
in. It's
Probably
kinda
2.
funky, so it looks like it could be a weird beat.
This is what you're doing in PFI.
Yeah, you, like the U.
Well, I mean, yeah, and if you're like trying to assume what the name is, it does look like you. You might be like, oh, maybe it's a bee with a weird tail.
Dao-yo.
That is.
I got a cool box with like weird chemicals written on the back.
Do you want us to put infinity or
Yeah, go ahead and put your infinities in. Open in darkroom only. I'm going for it, man.
What? This is not a. This is a very well lit room.
I'm going for it. Ha, it's only business cards. I spelled my name right.
It took me a long time before I realized that I was pronouncing your name wrong.
Oh, that's okay. I've done that with students.
Yeah.
I've had some students for like 2 years, and like at graduation, they're like, by the way.
That's funny.
Yeah.
Did you, I probably don't even remember, but did you have Alex Potamaskin in your class?
What's the last name?
Potamaskin. It was like years ago.
Yeah.
Actually, he did have your class. He had green spiky hair back then.
That's possible.
It's been quite a few years.
Yeah.
It says art.
Yeah. That says art. So if you're doing multiple things and it doesn't matter what order you do them in, you can do them all on one picture. So you can relax all 3 of those, yeah. But then if you're going to change one of those to something else, go down to a new picture.
No cutting.
My life is full of
No.
writing H.
That's too much writing.
Yeah, it's a lot of writing.
So these get
I should do this off because I don't know what the answer is.
the way you made it, you're not gonna really have to change anything.
Now we relax Oh yeah, and keep track of the path while you're doing this, since you got space on here.
Whenever you're crossing out.
Yes.
I cross out this one.
Order matters, right? Because they have to do.
So now we need to
Also, we have to go
we need to
from.
move down to this next one.
We did your name, right? And we decided we're gonna go to.
But we're
Now we have to
further
go to
relaxing here.
No, because it's fine.
Yeah, but we have to show it. I don't like this.
So how, next one is 4, so B,
Yeah, no.
and then relax F. Now we have 5 and 5, so I guess we're
And then we're gonna smack all these.
and then F is 6, so we don't have to
We're visiting him, right?
Oh, we have to visit the smallest. So yeah, it's the same.
You can pick one, doesn't matter.
Okay, now we can.
Relax.
Yeah, yeah.
No, yeah, that should have been long.
And then, now we have this, and then we got an and we have to, and then E is for their five, right?
The only option for no
Do we visit page? Yeah.
More option for no.
Yeah, because the next visit would have to be changed to that one page.
Yeah.
Oh, we do.
Like, it's the same kind of thing where like, you can throw like a big line, and the point you were at, you go on, that is
We're on this page.
Relax again. So we'd have to go to the next year.
Okay, well.
Because see, now we're redoing it, so we're at 12 and then we're dropping a little bit, so we have to figure out.
Now, you go on.
Do we have to?
We might as well.
Right?
It's fine.
So next we're gonna.
guess
It's
not that hard.
Right? Now that the same is part, we pick one. So now we can visit E, we can visit F.
Yeah.
He also wants us to write down the
So
path.
let's say we want to visit.
And this gets the path of the ground, or?
No, to get to each one.
That was no point.
Yeah, now we're gonna visit. F equals,
So this path is way over. This path is 85.
To get to F, we have to have A, B, H,
Just trying to figure out.
Oh, yeah.
H.
Okay, yeah. It can be a lot of writing, but.
Yeah. So yeah, this one's short.
Alright, I'm still getting the E.
Visit that.
right, but since it
Is 5, so it doesn't matter between 1 and 2.
So, why did you visit that one or that one?
This is why we keep track, because then you see which one you did.
The shortest one we get from F are the A, B,
Yeah, and H
This is
is
2, and this is 1, and this is 4. So you visited D next, you relaxed from that, so this became 5. So now you have 5, 4, and then 2. That would be the next one you would
Do you
visit.
do like A, B, F, E, H?
I got extra copies if you want.
I wonder if that would be a thing. Probably not.
Would it be faster than just going from O to H?
So you start off.
Because F is 5, E is 5.
So you go 4, 5, 6.
Yeah, versus just going E makes it easy.
And in that case, we did. I guess it doesn't matter which way you want to H.
Oh, wait.
There. So I wrote down H.
F, so we're gonna relax.
They already relaxed.
Oh, ADD.
Oh, okay, so that was 5, this was the first.
Oh, it's okay, no, it's fine, it's okay, actually, yeah. So AC, circle, and that's.
Still weird to me.
Because that's the shortest path.
Yeah.
AC,
Because you have to do
Gum?
that before it gets going.
Water. I went out for work. I'm asking myself. It was not a Monday, it was a Tuesday.
It's even worse. It's worse than.
So you know it's hilarious. So Mardi Gras is called Fat Tuesday.
Where'd you get salmon?
It's Tuesday, it's like the traditional thing.
Oh, it's salmon.
And my friend at the bar
I thought you wrote that.
as the bartender. Did you have Mardi Gras on the weekend? Or no, I think he said something like, "Have you ever had Mardi Gras on a weekday?" And I was like, so. He felt so stupid.
You have to
Because it
go
was Mardi Gras.
do stuff on Wednesday.
I know. I took today off, but I forgot about school. And then because I'm cured. So many times I skip the first 2
So I think you guys are around that. When you're writing this up, right, anytime that
really bad
there's
when
a
I
changing,
again.
go down to a new picture.
I really didn't want to miss
Okay,
it.
so if you're starting here, I'm changing these to, you know, from infinity to 4, 1, and 2. I can put that on one picture, right? And I got my A circled because I'm starting there.
So she gives you like a free week where you can.
And I'm gonna visit
get
D.
really bad
Okay.
grade on your posts and stuff, but you just.
When I'm relaxing D,
That's
click
nice.
on the
Who is it?
picture. Because otherwise, it's not clear, did I visit that or did I relax
I tried to
that
take
from
her down
A,
through
right?
class.
So you want to be able to do what we were doing just here, which is go back and see exactly
I already
what
took
you did at each
Complete
step.
and failed, so I have to take it again.
And if you're doing 2 things and I'm relaxing 5 nodes
I
here, I
had
can put all those
so
relaxed
much
nodes
that
on one
happened
graph.
that
After
year.
that.
And then this
But
term,
once I'm gonna do
give a
something
backpack
different,
stolen,
and if I get this on an exam,
Had some issues
I'll do
going
like
on for
this kind of
that.
thing.
Those
Try to
stores.
multiple
So I
copies
took
of
it back to back.
Part 1, part 2,
And I did better the first time than I was right after.
Okay. So then the answer, yeah.
But I'm not going to my first quarter.
So you, yeah, so you take the pointer and fail, this one made her keep going. And then add it on.
Cool, okay.
Just terrible teacher. I was talking to my.
Okay, anybody not end up with 10?
Calculus 1 teacher.
Yeah.
Who was that?
So do we move on to the
Elijah.
a new
I tried to get him
So
my Calc 2.
this business of moving on to a new, right, you got multiple copies. The idea is, when I'm grading this, I want to know exactly what you did. Okay, so if you've got a node circled and you're relaxing 3 nodes adjacent to that, you can change those 3 nodes, okay, in a picture. If I'm going to relax a 4th node in a future step, move down to a new picture. So that I know that first you relax these 3 nodes, and then you circle the one that was closest, right? If you have one picture, and you keep changing the values of nodes and keep visiting different nodes and it's all sitting on one, it's really hard to look at that and know exactly what you did at each point. So if there's any ambiguity about when you're going to do something, move down to a new picture. Okay? And I'll give you enough copies of this on a test so that you can, you know, keep moving down to another. So everybody got an answer of 10 at the end? Right? You got a 12 tentative and then that got relaxed to a 10? Okay, so that's Dijkstra's algorithm.
My calculator.
So I may give you a real simple Dijkstra's algorithm on Friday for your quiz, but I'll definitely give you some combination permutation questions. Okay, because I think people are up to speed on that. But I may give you a simpler Dijkstra's algorithm. But if I give you a really simple graph and ask you to use Dijkstra's algorithm, don't just look at it and say, oh, well, it's got to be this because that one is 30 and that's way too big, right? I'm going to make it simple so that you don't have to spend, 30 minutes writing down weights and stuff, but I still want you to use Dijkstra's algorithm, okay? Visit nodes faithfully and relax and so on and so forth. Is that clear? Cool. So, any questions on graph theory, Euler paths, representation of graphs? All right, well, let me get a start on what we're going to wrap up with, which is languages and automata theory and stuff like that. This could be an entire course. When I was in grad school, there was a whole course on automata theory. But let's look at this question of formal languages. So just kind of a lead into the topic here. English sentences, typically you have like an article, you have a noun, and a verb. Okay, and a period. So that's one version of a valid English sentence. The dog barks. And if we have a sentence, we can say, is this a valid sentence? And one way of answering that question is, well, if it's an article followed by a noun followed by a verb, then it's a valid sentence. And so we can get sentences like, the sky sleeps. And syntactically, that's valid. Semantically, we could argue about whether that's actually meaningful. Can the sky sleep? What does that mean? Well, maybe it means it's nighttime. Maybe that's the way my people refer to sunset. But is that meaningful, right? So we're going to be concerned with syntax for the next week. Okay, what is valid syntax? And let me give you a programming example. If I equals I equals I plus 0, I equals I times 1, I equals I, else I equals I. Is that a valid snippet of C code? Can I compile that and it'll run? Absolutely. Compiler will look at that and it'll say, oh good, someone who knows how to program. I'm so tired of syntax errors. And it'll compile it up, right? But semantically, meaning-wise, this is sort of meaningless, right? Because it doesn't do anything. I mean, it takes CPU cycles, but it doesn't accomplish anything. It may as well just be a comment. So we're only interested in syntax and what we're going to be talking about. So if we have a sentence, so Noam Chomsky has all these great sentences. The colorless green gas is noisily quiet, or something like that, right? And as a structure question, is this the valid is the structure of a valid sentence? Yes, absolutely. Does it have any meaning? No. You can't have a colorless thing that's also green. You can't be silent and noisy, right? But we're not worried about the meaning of things. So a compiler looks at the structure of this. Do I have matching parentheses, braces, semicolons, all that stuff, right? And that's what we're going to be looking at, is the structure of a language. No concern for the meaning, okay, whether it makes sense or not. And our first question is going to be, how can we define the syntax of a language? How can we come up with some way to know whether something is valid in our language? And language is a general thing. It could be C programming, it could be words, it could be sentences, it could be pictures. Okay, but language is a general term for things that we're going to look at and ask whether they're valid or not. And there's a number of ways we can decide whether something's valid. For example, if you have a collection of letters, we can say, is this a valid word? And there's some ways to do that. One, we can look for rules. If there's a Q, is it followed by a U? Does it contain at least one vowel and it's not the word syzygy? Things like that, right? So there's tests we can apply. We have a really simplistic way of knowing whether a word is valid. We have a lookup table we can use. It's called a dictionary. And you go through and you look for the word in this big long array, and if it's in there, it's valid, and if it's not, it's not. Right? Depending on the dictionary you use when you're playing Scrabble. So we can make a list of all the valid sentences or words, or we can come up with ways to test something to see if it's valid or not. Or you can come up with ways to produce valid things and see if this is producible from those rules. So how many people here have played Mad Libs? Mad Libs is awesome, right? So it's like the noun, verb, and noun, blah, blah, blah. And you just fill in, you say, give me a noun, give me a verb, give me a noun, you end up with a sentence. And the sentence will make sense syntactically, but it'll come out kind of crazy, right? So this is a way that we can produce things that are syntactically valid. So this is a third way to get our handle on syntactically valid things in our language, is to come up with a set of rules for producing valid strings, words, sentences. And that's mostly what we're going to play with, is production rules for forming what we'll call sentences. And then if something can be gotten from those production rules, we're going to say it's valid. And if it can't be gotten from those production rules, we'll say it's not valid. And that's going to lead us into this general area called automata theory. It's going to lead us back into state machines from 250. And in some ways, it'll eventually lead us to Turing machines, which is where we start to talk about models of computation. So as we go through this last part of the course, I'll try to tell you the stuff that I expect you to be able to do in great detail. I'll tell you the stuff that I expect you to just kind of like sit back and enjoy and think about, and you'll see it again. And there's going to be a lot of that latter stuff. Okay, we're going to fly through a lot of material, but mostly we're going to want to know how to work with what are called phrase structure grammars and Turing machines and a few other things like that. So, okay, so quiz on Friday, predominantly on Chapter 2, combinations, permutations, product rule, things like that. Probably a simplified Dijkstra's algorithm question also. And then we'll launch into formal languages the rest of Friday.
I knew it. I'm not surprised.